What a pretty little guitar part there. Well, okay, students, so we are going to today work on 7.2 in trigonometry. So this is where we get into the right triangle trigonometry. Okay, so we'll start off like we do a lot of sections. We need to learn some terminology. A lot of this you've learned before, probably in high school geometry. Okay, so to start with, we're going to look at the definitions of the 6 trig functions. So you need to know how this relates to a triangle, and you need to know the parts of the triangle. So if you have a right triangle, there's always one right angle. And of course, a right angle is 90 degrees. And then there's 2 acute angles. Okay, what acute means is an acute angle just means between. We talked about this, I think, before, between 0 degrees and 90 degrees. So you'll always have your other 2 angles being acute. The longest side, the side of a right triangle, you may recall, is called the hypotenuse. So I'll use that terminology quite a bit. And then the other 2 sides that are opposite the acute angles are going to be called the legs. So this diagram that I provided shows you that. You have a right triangle. This is, of course, your right angle. Angle B and angle A are the acute angles. The hypotenuse is the longest side of the triangle. And then A and B are called the legs. So the legs come together to make the right angle. Okay, when we're doing these triangle problems, one of the things you want to do is understand the standard way to name a triangle. So what we do is we use uppercase A, B, and C for the angles. So you can see I've got angle B, angle A, angle B, angle C. Lowercase are the sides. So I have A, B, C. C is always going to be the right angle. Okay, that's just the standard. And then the lowercase c is going to be the hypotenuse. And I think I made a typo on this. I think this should be lowercase a is the side opposite A, and lowercase b is the side B. So you probably want to make that change on this. So the way it goes is A is opposite angle A, B is opposite angle B, C is opposite angle C. Okay, so that's the standard naming convention and the parts of a right triangle. That's the first thing I want you to get down. Okay, now in trigonometry, we're going to start by looking at how trigonometry relates to a right triangle. So there's 6 trigonometric functions. The reason there's 6 trigonometric functions, because if you take a triangle, it turns out that there's 6 ways to form ratios of the 3 sides. Okay, so first of all, we have the sine, cosine, tangent, cotangent, cosecant, and secant. Those are the names of the 6 trig functions. And these are the abbreviations, SIN, COS, and so forth. Those are abbreviations. And what you want to do is you want to kind of look at this. You want to know these definitions, and you do need to memorize these. I don't give you these things. And in trigonometry, there's a lot of things that you have to memorize, so that's something you're going to have to get used to. So what we do is if you look at angle theta, I'm talking about in relation to angle theta. The sine is defined to be the side opposite over the hypotenuse. Okay, a lot of times I just abbreviate that as opposite over hypotenuse. Okay, the cosine is defined to be the side adjacent. That just means the side that's next to theta over the hypotenuse. So in relation to theta, this is opposite, that's adjacent, that's hypotenuse. That changes if you go to this top angle like that. Okay, so that's adjacent over hypotenuse. The tangent is the opposite over the adjacent. Okay, then the cosecant is backwards of the sine. So notice it's just reciprocal. If you turn this upside down, you get the cosecant. So the cosecant is the hypotenuse over opposite. The secant is the reciprocal of the cosine, so it's defined to be hypotenuse over adjacent, like that. And then the cotangent is the reciprocal of the tangent, so it would be adjacent over opposite like that. Okay, so those are your 6 trig functions and how they relate to a right triangle. So you want to get those definitions committed to memory, and we're going to work a little bit in this section on how to use right triangles, use trigonometry to find other parts of a triangle, and so forth. Okay, on the next page, a couple of things that you want to notice. And again, these are the definitions. So notice sine and cosecant are just reciprocals of each other. Opposite over hypotenuse, hypotenuse over opposite. So the cosecant is the reciprocal of the sine of theta. The secant, secant, what's going on? Hold on just a second. Let me fix this. Okay, just having OneNote problems. OneNote's a kind of a great program conceptually, but man, it has a lot of bugs in it. I have to constantly shut it down and reboot it. Okay, so the next thing I want to do is secant and cosecant, or I'm sorry, secant and cosine are reciprocals, and then cotangent and tangent are reciprocals. So the thing is, if you know the definition of sine, cosine, and tangent, then you can easily just flip them upside down to get the other three trig functions. Okay, there's a lot of ways to memorize. I guess this is supposed to say one way to memorize the definition of the six trig functions. This is the common way that teachers do this. So if you're doing the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. Then the tangent is opposite over adjacent. So that spells out what kind of sounds like a Native American Indian word, I guess. Sohcahtoa is what it reminds me is a Native American language or something. So that's one way to do that, is to memorize sine, cosine, and tangent. And Sohcahtoa is one way to do that. A lot of other ways to do that too. One time years ago, I had a contest in my class. This is back years ago when I taught high school. And I said, I'll give you extra credit if you can come up with something that makes me laugh. Okay, so a student came up with this one time. They had sine opposite hypotenuse, and then they had cosine adjacent hypotenuse, and tangent opposite over adjacent. And then they said, Oscar has a hairy old ass. So yeah, that made me laugh, so I gave that student extra credit. So that's just, you write down sine, cosine, and tangent. You say Oscar has a hairy old ass. So anyway, I just thought I'd throw that in and tell you that, because I think that's kind of funny. I still remember that from years ago. All right, so we go to the next page. What we're going to do is we're going to kind of get comfortable with, if I give you a right triangle, how to write these six trig ratios like this. So the first thing is, this is my standard triangle. And I'm just going to fill in what we have. You should do the same thing. We have side A is 3. We have side B is 4. Now we need to find side C. So the Pythagorean Theorem, and students always learn this at some point in middle school or something. The Pythagorean Theorem is how the sides relate in any right triangle. So it's just the square of the hypotenuse is the sum of the squares of the two legs. So I'm going to replace 3 with A, so I'll have 3 squared plus 4 squared equals C squared. That would be 9 plus 16 equals C squared. And then what I end up getting from here is I get 25 equals C squared. So what number do you square that gives 25? Yeah, you would get 5. Now what you do to solve this equation is you square root both sides. So the square root of 25 is 5. And the square root of C squared is C, because C times C is C squared. So what we get is we get that side like that. Okay, now anytime that you have 3 whole numbers, okay, this is called a Pythagorean triple. So anytime you have 3 whole numbers that satisfy the Pythagorean theorem, that's a Pythagorean triple. There's an infinite number of possible numbers that make the Pythagorean triple. 3, 4, 5 is one of those. Okay. All right. So what we're going to do then is we're going to find. I'm going to kind of write the definitions as I go. So the sine is opposite over hypotenuse. The cosecant is hypotenuse over opposite. So the cosecant is just the reciprocal then. So here's what you do on this, okay? We're going to look at angle A, and then you focus on, okay, what's opposite? Okay, 3 is opposite. What's hypotenuse? 5 is. So that means the sine of A would just be 3/5. Okay, on the cosecant, again, if you look at A, it's hypotenuse 5 over opposite 3, so that's 5/3. Okay, so those two things right there are basically just going to be your trig ratios for those things then. Okay, now what we're going to do is we're going to kind of refocus on the next one. We're actually going to go to angle B. So again, I'm going to write down what these are. This was 3, that was 4, and we found that to be 5. So what I'm going to do is I'm going to highlight the B, and I'm going to kind of talk out these definitions. So the cosine is side adjacent over hypotenuse. Secant is reciprocal of that, so it's hypotenuse over adjacent. Okay, so if you look at this, if you look at B, the opposite is 4. The hypotenuse is 5. That never changes. But the 3 is the adjacent. So the cosine would be adjacent 3 over hypotenuse 5. Okay, so that would be the ratio. The secant's the reciprocal of that. So that would be 5 over 3. Okay, so in relation to B, 4 is opposite, 3 is adjacent. The hypotenuse is always the hypotenuse. Okay. Now what we'll do is we'll go back to angle A, and we'll kind of focus on this. So the definition of the tangent is opposite over adjacent. The cotangent is adjacent over opposite. Okay, so if you look at A, opposite's 3, adjacent's 4. 5's the hypotenuse. So the tangent's just going to be 3 over 4. And then the cotangent would be adjacent 4 over opposite 3, so those things are reciprocals of each other like that. So that's kind of the first thing that you want to know how to do is know your definitions, take a triangle, be able to write those 6 ratios correctly. All right. Okay. So let me move down to this next one here. And again, what I'm going to do with this one is I've given you the sides. So this one, A is 2, C is 3. We got to find what B is. Okay. The other thing you want to know is if this is side A, then the angle opposite would be represented by capital A. If this is side B, then the angle opposite would be B. And we always use C, capital C, to represent the right angle. So that's how that triangle would be set up. So we need to find B. So let's start by writing down the Pythagorean Theorem. Okay, a squared plus b squared equals c squared. So if I give you 2 of the 3 sides, you can always find the third with Pythagorean Theorem. So we'll plug 2 in for a, and that would be 2 squared. Just leave the b squared alone. And then c, plug that in, so you'd have 3 squared like that. So just plug in the Pythagorean Theorem. Okay, that's going to give 4 plus b squared equals 9. Then you want to move the 4 over there, so you can do this in your head. You're just subtracting 4 from both sides of the equation. And then from here, that would cancel. That would give you b squared equals 5. Now you do square root of both sides. So you would get b equals square root of 5. Now square root of 5 is what we call an irrational number. And it'll have decimals. I don't want you to get decimals. I want you to leave it alone. So just notice if you did square root of 5 on your calculator, you get all these decimals that repeat, and it's what we call an irrational number. The decimals go on forever, but they have no pattern. You couldn't predict what comes after the 7. Okay, it's kind of like the number pi. It's the same concept. Okay, so what I'm going to do on this, I'm going to go ahead and put this in as b is now square root of 5. Now we've got the 3 sides, so now we're ready to start looking at our diagrams then. Okay. All right, so I'm going to kind of write down the definitions as we go. The sine is opposite over hypotenuse. Okay, so what we do is we look at angle B, focus on angle B, and look at the opposite, square root of 5, and the hypotenuse 3. So that's going to be side opposite over hypotenuse. That's square root of 5 over 3. Now, you've got to be careful, okay? Don't do the reciprocal because this is a different angle. The cosecant is the reciprocal of the sine, but that's a different angle, so it's not going to be the reciprocal of this. So the definition of the cosecant is hypotenuse over opposite. So what you do is you look at angle A. So if you look at cosecant of A, you focus here. Opposite A is 2. Hypotenuse is 3. So that would end up being, oops, I did that backwards too. So let me correct myself. Sorry about that. Okay, so if you look at A, the hypotenuse is 3, the opposite's 2. So that would be 3 over 2. Okay. All right, now we go to the cosine. The cosine's definition is adjacent over hypotenuse. Okay, look at angle A and talk it out. Adjacent is root 5, hypotenuse is 3. So that would be root 5 over 3. Okay. The secant is hypotenuse over adjacent. You're looking at the secant of B. So you look at hypotenuse 3 over adjacent 2. Okay, like that. Okay, so if you're looking at angle B, it would be hypotenuse 3 over adjacent 2. Okay. And let's see, finally, the last set here, tangents opposite over adjacent. So if you look at angle B, right here, opposite is root 5, adjacent is 2. So you would have root 5 over 2 like that. Okay. And then the cotangent would go like this. It would be adjacent over opposite. So again, you're looking at angle A, so adjacent is square root of 5, side opposite is 2. Okay, like that. Now I'm going to do a couple other things with this problem that I want you to write down. On this particular problem, I'm going to go through and just do a couple other ones. Let's say that we're doing the, let me give the kind of what I'm wanting to show you here. Let's say that we're doing the secant of A, and let's do that. Okay, so the secant of A would be hypotenuse over adjacent. So what would that be? 3 is hypotenuse, adjacent is 5. So I want to do that because none of these problems worked out like that. So one of the things that you do is you don't want a square root in the bottom. So what you do is you do what we call rationalizing the denominator. Okay, and you'll do this throughout the semester in trigonometry. So if you haven't done this before, it's real easy to learn. The idea is we don't want that square root to be in the bottom. That's just a preferred way of writing that. So what you do is you multiply the bottom by square root of 5, and whatever you multiply the bottom of a fraction by, you got to do the same thing to the top. Okay, and when you do this, you'll have 3 times square root of 5. Okay, you can't get 15 because the 3 is not under a radical. Then you'll have square root of 5 to the second, or 25. Anytime you do the square root of something to the second, the radical comes off. So the answer you would get is 3 root 5 over 5. Okay, now that's something you're going to do frequently. So anytime that you have a square root in the bottom, rationalize it by multiplying by that radical. Okay, if that was a, for instance, one more thing, like if you had 1 over root 2, you would multiply by root 2 over root 2. The numerator would be square root of 2. Denominator would be square root of 2 squared. So you'd have root 2 over 2. Okay? Because really that's square root of 4. So that's something you want to be definitely aware of as you do these. Okay? Okay, so let's see. I'm going to let you work a little bit now. So just to kind of see if you know what's going on. So let's go to the next page, and I'll let you do the next 2 problems on the next page, which would be page 4. And go ahead and pause the recording, and then come back and check your results. Okay, so I'm going to go ahead and show you what you should have got. Now, I noticed on problem number 1, I don't know if you noticed it or not, but I had a mistake. And I took this diagram right out of the internet, and I guess wherever this came from was either a mistake or it was an intentional problem to see if students were paying attention. I went ahead and did the problem this way. So what I went ahead and did is, one of the things I said is we always use C to represent the right angle, and we use B. So if you didn't do it this way, you can get it corrected. This certainly was intentional, so I apologize about that. So what I did is we had, remember, side A is opposite A. Oh my goodness, now I've got everything messed up. So I'll tell you what I'm going to do, and this will be just as well since that was messed up. I'm going to go through and just redo all this stuff. All right, I didn't even notice that. I took that off the internet, and every now and then you'll find diagrams and stuff that are mistakes. And I mean, you could use B for the right angle, but that's not the standard way you typically do that. So, all right, let's just do this together then. That was intended to be B. That was intended to be C. And then this side would be A. So A is 5. The opposite of B would be B, so that's 12. And then that would be C. So that was the intention. Okay, I should have caught that as I was going through that. Okay, so we're going to use Pythagorean Theorem. So what is that? That's A squared plus B squared equals C squared. If you did this wrong, just erase it and do this along with me here. And then we'll have 5 squared. So we'll have 5 to the second plus 12 to the second is equal to C to the second. Okay, that's going to be 25 plus 144 equals C to the second. So that would be 169 equals C squared. Then you square root both sides, and if you need to use your calculator, you can. So C would be 13. Okay, so you get 5, 12, 13 is another example of what we call a Pythagorean triple, because all of the sides of the triangle are whole numbers. Okay, now we should be able to put this together okay. All right, so we're going to look at, let's focus at angle A. Okay, like that. So the definition of the sine is opposite over hypotenuse. So remember, SOHCAHTOA, the SO is the sine. So opposite would be 5. Hypotenuse would be 13. So that would be 5 over 13. Okay. The cosecant of A is hypotenuse over opposite. So that's just going to be the reciprocal. That's going to be 13 over 5. Remember, those are the same angle A, so that's why they're reciprocals. Okay, the cosine, we're now going to focus on angle B now. So I'm going to just kind of highlight angle B. Then we talk it out like this. So the cosine is adjacent over hypotenuse. So if you look at B, adjacent is 5, hypotenuse is 13. So that's 5, 13. There's a reason why that turns out to be the same as the sine of A. We're going to learn that a little later in this section. Okay, then the secant of B is hypotenuse over adjacent. So if you focus on angle B, hypotenuse is 13, adjacent's 5, so that's going to be 13 over 5. Okay, and then the last one, the tangent is opposite over adjacent. So we'll go back to focusing in on angle A this time. Okay, so just look at this angle right here and then talk it out. So what you'll have is opposite A is 5, adjacent A is 12, so the tangent is 5 over 12. Okay, then the cotangent is adjacent over opposite. So if you look at that, look at angle A, adjacent's 12, opposite's 5, so that's 12 over 5. So that's what was intended on that problem. If I would have had the angles right, that's what you should have got. If you didn't get that, and that's my mistake, I apologize for that. Okay, so generally I'm always going to give you C is the right angle. A and B are interchangeable, but C is supposed to be set as the right angle. Okay, now let me get down to this next one here, and let me kind of show you what I did here. Now this time I wanted you to draw a triangle. Your triangle may not look exactly like mine, but what you have to have is use C for the right angle and then use A and B. Those could be interchangeable, but the key thing is side A is opposite A, and that is something we had to find. And then side B is opposite B, that was given C as 6. And then side C is opposite angle C, so that was given as 7. So I did the Pythagorean Theorem on that. Just when I plugged that in and solved that equation, then you would end up getting the square root of 13 like that. Okay? Now let me just kind of go over what you should have done on this. So when you look at the sine of B, the sine of B is opposite over hypotenuse, so the sine would be 6 over 7. Okay? The cosecant of A is hypotenuse over opposite. So if you look at angle A, then you would have hypotenuse over opposite would be 7 over root 3. And then notice I rationalized denominator, so I would be looking to see that you rationalize the denominator. Okay, cosine of A. All right, focus on angle A. Adjacent is 6, hypotenuse is 7, so that's 6/7. Secant of B, look at angle B. The secant is hypotenuse over adjacent, 7 over root 13, just like the problem above. Rationalize denominator, you get the same thing. So again, what you're doing is multiplying by root 13 over 13 to get that answer. Okay, and then finally on the last row, the tangent of B. So if you look at B, opposite is 6, adjacent is root 13. So you'd have to rationalize that denominator. And that's how you would do that. So you should get 6 root 13 over 13. And then the cotangent of A, look at angle A. Adjacent is 6, opposite's root 13. And again, same thing, you rationalize the denominator like that. Okay, so what I've done on this is real fundamental. It's once you get the definitions down, there's nothing to that. But you do need to make sure you know how to rationalize denominators and use the Pythagorean theorem to find a missing side. So I'll kind of take care of the first main thing that I want to talk about then. All right, so I'm going to move on now to the next page. And then we're going to, I'm going to go ahead. Actually, I'm doing this recording in 3 parts, I decided. So I'm going to go ahead and do the part 1 as a recording, and then that'll be posted. Okay, so hopefully that helps you to kind of get started on this part.